I would like to open this session on time.
Okay.
Dear Professor Gong, President of WFEO, dear friends, welcome to this webinar organized by WFEO, taking the occasion of the 23rd China Beijing High-Tech Expo. My name is Peng Jing, Chair of WFEO's Committee on Engineering for Innovative Technologies. It's my great pleasure and honor to be the moderator of this webinar. The theme for today's webinar is A Sustainable Future, Young Engineers and Fourth Industrial Revolution. We are very pleased and honored to have invited four speakers. They are Professor Gong, President of World Federation of Engineering Organizations, WFEO. Mr. Yohan Ramasundara, member of AI and Big Data Working Group of WFEO. Also, immediate past president of Australia Computer Society. Ms. Carol Tai, product owner of Digital Manufacturing, SAP. And Mr. Firas or Diab, Chair of WFEO Young Engineers Future Leadership Committee. First of all, before I invite the speakers, I would like to invite all of you, my dear friends, those online and in the site, to have a virtual tour to the WFEO's exhibition stand in the site of the 23rd China Beijing High-Tech Expo. We are very honored and pleased to have our president, Professor Gong, to be our guidance to the exhibition. Professor Gong, may I have the pleasure? Please, you show us.
Okay. I would like to show briefly about the exhibition stand. Let's start here. Here you see a tree that is we analog the WFEO tree in our logo. And you see every leaf in different color, that's the STG color. And behind the tree is a very large screen. Here is by the text in the document, the UN Sustainable Development Agenda. And also we give some figures to show how important to get rid of hunger and so on and so forth. And here you see the figures. And you could also see the language of every goal. We use 6 UN official languages. And after showing the goals itself and the relevant figures and data, you will see selected great scientists, engineers. How can we change to that screen? Okay, let's go forward. Actually, we have gathered a lot of data to show, to explain the goals. And we use the pictures of WFEO activities here to show how engineering helped to achieve the goals. And we have selected 17 distinguished engineering projects in the history, and 17 distinguished scientists and engineers, but we need to wait a few minutes to see that. And you can scan this code and to get the video and the materials of this exhibition. Oh, here you can see the 17 great engineers, great scientists from all over the world. After showing the 17 scientists, you will see 17 distinguished great engineering projects in the history. So this part is the communication part, and we have the SDG circle and the chairs including the SDG colors. And this screen we are going to use as the main screen for our webinar. So that's a very brief introduction to the exhibition. The theme of the exhibition, I think you can guess, that is engineering for sustainable development. Professor Peng, I stop here.
Okay, thank you so much, Professor Gong, for the virtual tour guiding for us to see the framework of the exhibition stand of WFEO. And I think it's quite attractive and inspiring to see what the 17 SDG goals, the 17 engineers, and also the history of the WFEO. So let's move to the presentation time. And first, let me welcome Professor Gong K, President of WFEO, to give his report. Professor Gong, the floor is yours, please.
Thank you, Professor Peng. Welcome, and good day. I would say good morning, good afternoon, and good evening. Depends where you are. And today, I will address the theme of this webinar. Just as introduced by Professor Peng, the theme of today's seminar is sustainable development future, a sustainable future, young engineers, and the fourth industrial revolution. I think there are three key words. The first is sustainability, young engineers, and the fourth industrial revolution. As to the sustainable development, how can I, no, it does not work. I cannot turn the page over. So actually, first I'd like to address sustainability. Oh, there's some problem. So let's talk about sustainability. I think sustainable future depends on sustainable, successful transformation. So, you know, if we talk about sustainability, we will recall in the past development, along with the economic development and the social development, population growth, there are two explosions we call the dual explodings. One is the energy resource consumption exploding. Another one is emission of the various pollutant exploding. And these dual explodings causes such four negative impacts to the world. The shortage of resources, environmental pollution, ecological destruction, climate change. And these negative effects to the people's life, we see here's the number. There are 6 million people, 6 million young child die before the age of 5. The 40% of the population does not have access to sanitation. 2% of the world is not digitally connected. Today we talk about digital connection, but don't forget, more than half of the population in the world could not get access to the digital internet. About 30% of the global population lacks safety drinking water supplies. Climate impacts will push 100 million people into poverty by 2030. So, facing to such a severe challenge, people get together in 2015 in New York, in the headquarters of the United Nations, to have made an agenda which is called Transforming Our World, the 2030 Agenda for Sustainable Development. In this agenda, there are 17 Sustainable Development Goals was agreed to achieve by 2030. And these goals could not be achieved without contribution of engineering, so that we can say engineering is a key for achieving the Sustainable Development Goals. Just as pointed out by the Secretary General of the United Nations, Engineer Guterres, he said, when in his letter to WFEO's 50 years anniversary, in that letter he stated, we strive to achieve the 17 Sustainable Development Goals, the world's blueprint for building a future of peace and prosperity for all on a healthy planet. Every one of these goals requires solutions rooted in science, technology, and engineering. So that shows the fatal importance of the role of engineering to achieve the 17 sustainable goals. So, to carry out these responsibility of achieving sustainable development goals, WFEO, as a world's largest engineering organization, has initiated a campaign to have a World Engineering Day for Sustainable Development. And this World Engineering Day is approved by the UNESCO in the year 2019. So actually, we have already asked why Engineering Day for Sustainable Development. Because engineering is a key for sustainable development. Engineers are responsible for the sustainable development future of the mankind. But the question is, when is the World Engineering Day? It's the 4th of March every year. Why 4th of March? 4th of March is the birthday of the World Federation of Engineering Organizations. The engineering the World Federation of Engineering Organizations consists of more than 100 engineering organizations from different countries. We call them national members. For example, the Chinese Academy of Science and Technology is a national member of China. And we also have about 10 members, such as the European Engineering Federation, African Federation of Engineering Organizations, and so on and so forth. So WFEO, in short, World Federation of Engineering Organizations, is the world's largest engineering family. So the 4th of March is the birthday of WFEO. The vision of WFEO is to mobilize engineers worldwide to shoulder the responsibility for sustainable development of the humanity and planet. And the main functions of WFEO is to make the voice of engineering in the world, especially in the UN system, to build engineering capacity for sustainable development in all countries, especially developing countries, and to give better services to WFEO members. So to carry out this responsibility to achieve the 17 Sustainable Development Goals, we have to understand the goals as a system. We see 17 different goals in different colors, but the SDGs is not just the 17 independent goals, but an integrated system which could be characterized by 1, 2, 3, 4, 5, 6, and 0. That's my understanding to the system of these goals. What is one? One means one core issue. What is the one core issue? You see the 17 goals. We can divide it into 2 parts at first. Here you see the goals of human welfare. No poverty, no hunger, and so on and so forth. With human welfare. But the human welfare on the earth is limited by the earth's resources. So we have the goals about the limitation of the earth, climate change, biodiversity on the earth, and biodiversity in the sea. So there is the human welfare, natural cost. It's a tension of these 2 goals, 2 pairs of goals. And our task is to maximize this ratio, to minimize, maximize the human welfare and minimize the natural cost. How can we achieve this? We have these linking goals: clean energy, industrial innovation, resilient human settles and community, and so on and so forth. These goals are linking these 2 tiers of goals and to balance the development of the human society on the earth. So that's one. The core issue is to maximize this ratio. 2 means 2 layers. We have 17 Sustainable Development Goals. Under these 17 Sustainable Development Goals, there are 169 topics. For example, let's have a look to the goal 7, affordable and clean energy. And to achieve these goals, there are 3 targets. Only when we achieve these 3 targets, we can get achievement of the whole goal of these clean and for the affordable and clean energy. So we see the 2 tiers, 2 layers of the goal. And 3. 3 means 3 dimensions. As stated in the document of the 2030 Agenda of Sustainable Development issued by UN in 2015, it states the 17 Sustainable Development Goals and 169 targets, which we're announcing today, demonstrate the scale and ambition of this new universal agenda. They are integrated and indivisible and balance the 3 dimensions. What are the 3 dimensions? The first dimension is economic. The second dimension is the social. And the third dimension is environmental. So the sustainable development is not just about economic development or social development or environmental development. It's an integrated development, balanced, integrated on these three dimensions. So here you see a picture. We try to show these goals are mainly related to economic development, and these are mainly related to social development, and these are mainly related to environmental development, but they are not divisible. There's integrated goals. Now we come to 4. What does 4 mean? 4 means 4 levers, because the 17 goals, they are interlinked. So to have an integrated approach to achieve these goals, we need 4 levers. The first lever is governance. The second is economy and finance. We need money. The third one is individual and collective action. We need widely involvement from everybody, every organization, every society to carry out these sustainable development. And science and technology. Engineering is here. Science and technology is a lever to achieve the 17 sustainable goals. But you know, if we only have levers, we cannot make real impact to the world. We need some supporting points. We call the entry points. There are 6 entry points listed in the last year's Sustainable Development Summit in the United Nations. They have released a report called "The Future is Now: Science for Achieving Sustainable Development Goals." In this report, released in the UN Summit for Sustainable Development, there are 3 entry points: human well-being and capability. The first entry point. The third one is sustainable and just economies. The third one is energy decarbonization with access. Decarbonization and access are the dual goals of this. Food system and nutrition patterns, urban and peri-urban development, global environmental commons like climate change. So here we have 4 and we have 6. We are missing 5. What are the 5 means? The 5 means 5 key concepts. Let's read the text in the document. This agenda for 2030 Sustainable Development, is a plan of action for people, planet, and prosperity. It also seeks to strengthen universal peace in large freedom. We recognize that eradicating poverty, all its forms and dimensions, including extreme poverty, is the greatest global challenge and the indispensable requirement for sustainable development. All countries and all stakeholders acting in collective partnership will implement this plan. We are resolved to free the human race from the tyranny of poverty and want to heal and secure our planet. So here we see 5 P's: people, planet, prosperity, peace, and partnership. These 4 concepts we call the 5 key concepts in the sustainable agenda, sustainable development agenda. Finally, 0. What does 0 mean? It is indicated in the document. As we embark on our collective journey, the journey for sustainable development, to pledge that no one will be left behind. That is a zero. No one left behind. Because this is an overarching goals over the 17 Sustainable Development Goals. So 1, 2, 3, 4, 5, 6, and 0. I understand that's a systematic understanding of the Sustainable Development Goals system. So we have talked about the first concept of today's theme, sustainability. Now let's take some time to talk about fourth industrial revolution. The fourth industrial revolution is a revolution after the first revolution, which we call the mechanization. And the second industrial revolution, electrification. And the third industrial revolution, that's a recent one and still going on, that's informatization. We call it in Chinese, we call it 信息化. I could not find a single word to describe the fourth industrial revolution. But the core of the fourth industrial revolution, to my understanding, is the integration of three spaces. First is cyberspace, such as Internet of Information. And then the physical space, such as manufacturing network, energy network, and so on and so forth. And the third space is biospace, biomedical practices, and so on and so forth. The combination, the integration of these three spaces is a solution, so that to realize a green production and services, a green economy and a green society. Here I would like to cite from a book which is written by Prof, the founder of the World Economy, Forum, WEF, usually we call the Davos Forum. He said the easiest way to understand the fourth industrial revolution is to focus on the technologies. Organization of Economic Cooperation and Development, OECD, has identified around 40 frontier technologies that are actively participating in this revolution. Internet of Things, artificial intelligence, blockchain, autonomous driving, facial ID recognition, digital healthcare sensors, 3D printing, and so on and so forth. And the fourth industrial revolution offers a valuable platform and accelerates the progression of achieving sustainable development goals. So the fourth industrial revolution is linked with sustainable development goals. Let's have a deeper look to the fourth industrial revolution. First, I would like to say the pervasive interconnection, Internet of Things, Internet of Everything is the foundation of the fourth industrial revolution. So a few years ago, I have listened to a speech by the president and the connectivity gives new options for software innovation. Value is shifting from product to the cloud. The business model has shifted from products to services, just as people get free telecom service, a free cost mobile phone, if you have buying a, say, 2 years communication package from a telecom operator, for instance, China Telecom, China Mobile. just like this, washing machines, coffee machines, and treadmills, and other machines, even cars, could all be given away for free through services contract. So service will become pervasive based on Internet of Things, based on pervasive interconnection. So that is the foundation. Without interconnectivity, there will be no fourth industrial revolution. And data. Data is the fuel for the fourth industrial revolution. All the emerging technology we mentioned above is based on data. So data is the fuel or the food to the fourth industrial revolution. And then AI. What is AI? AI is the brain of the fourth industrial revolution. However, the fourth industrial revolution is not just about smart and connected machines and systems. Its scope is much wider, ranging from gene screening to nanotechnology, from renewable energy to quantum computing, from smart manufacturing to smart transportation and smart cities. It is the fusion of these technologies and their interaction across the physical, digital, and biological domains that makes the fourth industrial revolution different from previous revolutions. So here we see the combination, the integration of all these technologies. But the AI is the soul of these combinations. Sustainable development is the soul of fourth industrial revolution. These efforts the power of the manufacturing to achieve the United Nations Sustainable Development Goals. The technological advance jobs more accessible. In this crisis of COVID-19, we all experience help us to achieve development. He said, AI creates significant possibilities for the business production process. Manufacturing, for instance. AI drives the application of robotics, which avoids unnecessary production costs for material waste, time and labors according to available data sets, in turn for greater productivity and economic growth. Combining the use of AI can utilize data for effective control of sustainable production to reduce the CO2 emissions, carbon dioxide emissions. AI improves the effectiveness of public services and enhances government accountability and transparency. AI makes education, healthcare more accessible, which helps reduce inequality in the long term. So that is how AI helps us to achieve sustainable development. In summary, the fourth industrial revolution is a power for sustainable development. Finally, let's go to the young engineers like you. The young engineers will shape our sustainable future. As said in the document of the 2030 Agenda for Sustainable Development, we can be the first generation to succeed in ending poverty, just as we may be the last to have the chance of saving the planet. So the young engineers should be the first, but not the last. The first generation to succeed in ending poverty, not the last to have the chance of saving the planet. So as the first generation ending the poverty, you will shape the sustainable future in your own hands. So please allow me as a relatively elder engineer to give 4 suggestions to young engineers. First, to master necessary sustainable development knowledge and skills. Second, to master strengthened ICT skills for every engineering profession. ICT skills are not just required for electronic engineers, for computer engineers. ICT skills are required for all engineers. So you have to behave with higher standards of engineering ethics. Here you see the model code of WFEO for practice for sustainable development and the model code of practice, principle of climate change, the model code for responsible conduct with AI and big data. So these are dealing with engineering ethics. Every engineer should understand his or her responsibility to sustainable development of humanity and the planet, should understand the ethical issues related to his or her professional work, such as integrity, security, privacy, inclusiveness, and fairness, so that he or she with responsible conduct with engineering works. Engineering education should enhance the engineering ethics education in the curriculum. Fourth, last but not the least, to be capable to collaborate with inter-X teams. What is X? We talk about the interdisciplinary, inter-organization, international, intercultural, inter-X. So you need to work in team with people from different disciplines, with people from different countries, with people from different sectors of the society to address the complex problems, to break through the bottlenecks to achieving the sustainable development. Collaboration is the key. So in summary, let's go back to the whole theme of today's webinar, a sustainable future, young engineers, and fourth industrial revolution. First, a sustainable future depends on successful transformation. The fourth industrial revolution is the power of the transformation, and young engineers will shape the sustainable future. So the future is in your hand. Here, I end my presentation. Thanks for attention, and you're welcome to criticize and make your comments. Thank you, Professor Peng.
Thank you. Thank you so much, Professor Gong, for your such excellent report. Especially your addressing on the SDGs, your insight on why engineering is key for the SDGs and how WFEO is doing its contribution. I do very much like your overall figure of 1, 2, 3, 4, 5, 6, and 0. It's very impressive. So thank you once more. I think we will have Q&A session after all the speakers. So next speaker, let me have the honor to invite Mr. Yohan Ramasundara, member of AI and Big Data Working Group, immediate past president of Australian Computer Society. Yohan, please.
Thank you very much, Dr. Peng. It's a very hard act to follow after Professor Gong Key's really wonderful presentation. I really enjoyed, I learned quite a lot of things about the SDGs and how they're all interconnected, and had some amazing messages which hopefully would be consistent with what I want to say. So if we look at the enduring value of engineers, that remains in the name. As some of you would already know, it comes from the Latin ingeniator, meaning the one with ingenium, the ingenious one. So as engineers, we should be very proud we have such an impressive name. And engineers hold a well-earned high status position in our communities. The profession's ability to continue to attract really bright young minds keeps it relevant and flourishing. Look at Professor Gong Key as an example. The engineering profession has progressed quite admirably through the pre-scientific revolution, industrial and second industrial revolution, and the information age. Regulatory support and in some areas, monopoly status enshrined engineers as the trusted source of advice across many specialist areas. So from this really commanding position, in the future, if there is a threat to the engineering profession, that would be itself, nothing else. And if you look at complacency, government regulation or deregulation, internal division sometimes, competition, reduction in standards, profiteering, digital disruption, breaching trust, and sometimes misreading public sentiment, have weakened or unraveled many industrial behemoths and occupations. And engineering is no different. Even before the pandemic, many industries have been under quite a lot of pressure and scrutiny. So if you look at occupations, even the occupations like farmers, jewelers, even accountants and lawyers are feeling quite insecure. And no occupation can really rest self-assured. So often the entity itself is least able to see and deal with emerging threats. Sometimes we see self-centered interests, especially in leadership circles, or cultural inertia and norms blind the faithfully. So the very composition of engineering I feel like the very composition of engineering may hold the Achilles heel, because too many like-minded, left brain, similarly educated, and mainly male professionals in our profession. Facebook and big banks are classic examples of the cost of cultural dissociation. So to maintain a high public trust, the engineering profession must find more ways to review itself quite regularly and independently, and embrace diversity, address weaknesses, and accelerate cultural change. Some of you may know Joseph Schumpeter, who coined the term creative destruction. He coined the term to describe how technological progress displaces old industries with creative new ones. In an increasingly tech-led economy, the engineering profession is quite well placed to continue to be a major force for good. But most innovation is being driven by startups and small companies with limited affiliations with larger bodies. So if you look at the founders of many global tech companies, some of them never graduated. For example, Bill Gates and Mark Zuckerberg. So startups are focused on ideas, innovation, cash flow, and capital raising at the expense of profession-driven courses, memberships, and code of conduct. So my advice would be engineers must really forge ever closer links with innovation and find better and faster ways to assimilate and comprehend what's going on, or watch their status as a preeminent source of professional and trusted advice really dwindle down. If I look at another threat, is the diminishing value. It could potentially start in schools, progress to universities, who still designed along rigid industrial lines and conclude with mentors drawn from senior ranks, but who find their value diminished by the impact of rapid change. Growing pressure on engineers will be industry attempts to maintain profitability at all costs. So for example, investigations into Boeing and the crashes of 737 MAX planes found the company put pressure on employees like pilots and aeronautical engineers, and they cut corners. And the engineers working for the US Federal Aviation Administration, FAA, were found to be quite deficient in their knowledge. And FAA found also allowed Boeing to do compliance obligations normally performed by independent authorities. So the mantra of less regulation has really dominated government's thinking for the recent decades. But the more we pursue complex engineering and software endeavors, the more engineers must be able to stand their ground. So the engineering profession must provide better ways to encourage engineers to report adverse matters and protect them from repercussions. If you look further into the future, some predict that the singularity will be reached. Singularity is a point where technological growth is uncontrollable and irreversible. So it's not in engineers' interest for this to unfold. Engineers can be very proud of their profession. The profession's roots go back to Galileo's landmark publication, The Two New Sciences. Engineers remain ingenious in practice. But however, since the invention and the use of the nuclear bomb, mankind continues to add more ways to obliterate life. Even if singularity does not materialize, Stephen Hawking and Elon Musk raised extinction level concerns about runaway artificial intelligence. Agnostic capitalism and soulless tech industry are brutal instruments, consuming and disrupting with limited care. So the rate of change is accelerating exponentially and never been so globally impactful. Slow-moving institutions like governments and the lawmakers must really speed up to better protect humanity from what we have unleashed. With safeguards, we can benefit enormously from our own creative ingenuity. My background is ICT, Information Communications Technology, and I believe ICT is arguably the greatest general purpose tool currently invented by mankind. So history will show ICT will surpass importance of the wheel, the printing press, electricity, telephone, and light bulb. ICT with great engineering has turned the wheel into autonomous vehicles, the printing press into the internet, the telephone into smartphones that every one of us carry, electricity into megabytes, and light bulbs into Li-Fi. I'll come back to Li-Fi later. The greatest challenge is the rate of change we generate really outstrips humanity's capacity to assess and adapt. Our laws, politicians, banks, media, aged youth, and commerce seems to be strained. It is as if the very fabric of life is unraveling. And history tells us that we appear unable to resist something that makes life apparently better. Today, we are experiencing a glut of change and innovation, and this pace is going to only accelerate dramatically for the foreseeable future. So if the consequences of rapid change are only considered in retrospect, we career towards a very uncertain future. If we can only see as far as our computer screens, we are basically doomed. Engineers carry an ever greater burden to contribute to the protection of the future state. Humanity, for example, is not the only creature that inhabits this earth. Social, ethical, and moral obligations must inform and steer our innovations. Right now, technology is a force multiplier without equal, and tomorrow technology may become the actual force. So the speed of change, the quantum leaps mankind is making, and the disruptions we are causing are the warning signs of this transition. Personally, I never liked the term industrial revolution, which was coined by French and popularized by the Englishman Arnold Toynbee. In this lexicon, we are moving from the digital or the third revolution from, as Professor Gong presented, 1975 to present, to the fourth, which is well described by Klaus Schwab, the executive chairman of World Economic Forum. He says fusing the physical, digital, and biological worlds, impacting all disciplines, all economies, all industries, and even challenging ideas about what it means to be human. But when you look deeply at the third and unfolding fourth industrial revolutions, at the heart are the properties of the electromagnetic spectrum. Not just the obvious like electricity, radio, Wi-Fi, and X-ray. For example, the gigantic estimates of data that we seek to store, network, and utilize in the future leads to an inevitable global solution: light. The opening sentence of Albert Einstein's scientific paper about his particle theory of light in 1905 is considered to be one of the most revolutionary statements of modern times. He basically upturned long-held views about light's behavior and properties. His insights opened an infinite door of possibilities for industry and innovation. Similar to Stone and Iron Ages defined humanity's industry, leveraging the electromagnetic spectrum is the key resource defining our way into the next millennia. So, for example, putting aside quantum entanglement, nothing is faster than light. only digitized photons will handle the volume and speed of the data that we really demand into the future. There is another related revolution underway, and I thank one of my good friends and a technology luminary, Mark Lloyd, for this important insight. The last century of artificial lighting is being overturned by the rapid global uptake of light-emitting diodes. We call them LEDs. So LED uptake is being driven by its low energy footprint and its environmental benefits. The casualties of this paradigm shift include lighting divisions of GE, Osram, and Philips. But more importantly, LED is a digital chip and capable of many other things, including transmitting low-watt wireless power and data at much faster speeds than Wi-Fi. And the global standard for Wi-Fi transmission is not too far away. An LED will soon be in every physical space, street lamp and car light. So combine this with fiber optics, LED creates a ubiquitous synergistic global network of near light speed capacity. Fuse in artificial intelligence, facial and voice recognition, time of flight technologies, IoT actuators, cameras and sensors, and almost every unimaginable service can be delivered into your office, home, car, any recreational space via smart LED. So mankind's new world industries rely increasingly on the properties of the electromagnetic spectrum. The unfolding Internet of Light and our creativity accelerate opportunities exponentially. So instead of fourth industrial revolution, I call it that we are entering the photonic millennia, because photons traveling at speed of light is defining the next millennia. And as mankind really reach for the stars, it is now possible for us to imagine that one day we could use the resources of infinite space and restore our finite Earth, but with the help of our engineers. Trust. I wanted to touch on trust a little bit. I think trustworthy technology and technologists are crucial for social harmony, economic prosperity, and industry success as we move into future. A couple of years ago in China, one of the owners of a Mercedes-Benz S63 AMG smashed it up with a golf club in front of the dealership that sold him the car. And another owner of a Brisbane organized a 52-ton tank to drive over his Dodge. And last year, a friend of mine bought a new top-end V8 Range Rover Sport packed with computers and sensors and all the gadgets. All this cleverness led to major failures. And after a year, the car dealership wrote to my colleague and said they are none the wiser about the cause. So what really ages the modern cars is no longer the odometer reading how long it's actually traveled, but rapidly advancing technology. Soon, we know that autonomous vehicles will go mainstream. Tomorrow's car will be a room or office basically in motion. And freed of the process of driving and ownership, passengers can embrace new service offerings and move from for the accountants over there, move from a CapEx to an OpEx model. And passengers will only use these services if the technologies can be trusted. So tech-rich autonomous car is a portent of smart homes. Amazon has teamed up with Lennar, a big US builder, to offer turnkey connected homes. These homes use Alexa for voice control, Sonos for entertainment, and Amazon for tech support. And services like keyless entry, e-keys for friends, on and off-site monitoring, and answering the door from anywhere are just simply just the beginning. Under the Internet of Things, tech giants will eventually offer super operating systems covering your home, your car, your computer, your phone, all the appliances that you got. And small companies like the Autonomous Travel Suite plan to use autonomous vehicles as a mobile hotel suite. Imagine if you're in Australia, if you're ever visiting me, and then you're in a hotel suite on wheels, serviced by traditional, fixed place hotels. So tomorrow's transport will really search for the events and interesting side trips. Smart people in country towns could really write, trip software. Your vehicle will upload your wounds, your likes, and download the town's attractions to make your visit a lot more memorable. And all that said, the elephant in the room is always a technology, but more critically, the faceless technologists and engineers, the people behind it. So it goes beyond whether we trust tech to drive us about. It goes to the very fabric of our society. So do you trust the person in the town writing the local travel software? There was an Aussie movie, The Cars That Ate Paris. The town basically survives by causing and living off the proceeds of car accidents. The movie really stretches the imagination, but poor programming and malware exist. So we don't want our autonomous vehicle driving us up the garden path or home software inviting thieves to come in. Almost every industry relies on technology to maintain margins, increase productivity, and differentiate their products. So the tech industry is really busily innovating to meet these demands and create new demands. For a fast evolving industry, speed to market seems to be so critical, and too often consumers become collateral damage, like my friend who owned the latest car. The speed of change driven by the tech industry demands our collective attention. History shows that mankind cannot resist new productive technologies, despite opposition like the Luddites destroying the machinery in the industrial age. The best way forward is to build and strengthen structures that promote professionalism and ethical behavior and deliver consumer safeguards. And that's where the organizations like World Federation for Engineering comes in. We need to really create new ways to speed up our ability to assess the impact of the digital disruption. If governments, legal frameworks, and social structures, if they remain glued to the industrial age, then trust in engineering and technology-driven change will slow and foster more Luddites. So we must use technology and engineering and our creativity to restore our planet and make better communities. We must find and retain and support and celebrate people who make a difference. We must also regulate our actions and beholden to the will of the people. We must create jobs of tomorrow, design, build more smart things, and diversify our economies. We must also get better at defining what's good, and armed with this purpose, we should work fearlessly and relentlessly to deliver. So I remain really excited about our collective future. If you look at what medicine, science, mining, space exploration, and other industries have achieved using advanced technology, it's easy to conclude that the tech industry and engineering is a force for good, and opens new frontiers and solves big problems like the 7 SDGs. Humanity's potential has never appeared so limitless, but in saying that, the engineers must build trust and community institutions must adapt more quickly. With these changes, we can all prosper and look forward to tomorrow with a lot more confidence. Engineers must find ways to leverage and control technology for good, or we succumb to our own inventions. And I remain positive that young engineers can make the world a better, safer, cleaner, and a more stable place for us all to live in this really finite planet. Thank you.
Thank you. Thank you very much, Yohan, for your such an excellent speech with so many informative ideas and thoughts in depth. I couldn't agree with you more for the collective future and for the young engineers. Thank you once more. Next speaker, may I have the honor to invite Miss Carol Tai, product owner of digital manufacturing in SAP. Miss Tai?
Yes, I'm here. Yeah.
Yes.
Thanks, Dr. Gong.
PPT, yeah. Please share your screen.
Yeah, I just share my screen. Can you see it?
Yes, yes, please go ahead. Thank you.
Okay, thank you. Yeah. Hi, everybody. It's my pleasure to present on this session. So I'm from SAP Labs China. So today I would like to share, because I just heard the presentation from Dr. Gong, so it's very impressive. And today I would like to share the industry photo now, also the fourth industry revolution from the manufacturing industry perspective. So my presentation name is the Industry 4.0 Now, from transactional to data-driven business process. Yeah, so, okay. So I think, yeah, everybody already know about the four industry revolution. So here we can have a quick look on that. So we already know that the first industry revolution is enabled by water and steam to power the mechanical production facilities. And then the second industry revolution is empowered by the electricity and the source of dividing comprehensive work processes into simple steps to realize the mass production. And then the third industry revolution is enabled by electronic and IT system to realize the automation production. And now in 2013, we have the fourth industry revolution. It was enabled by something called cyber-physical system, which actually in Germany, this evolution is summarized under the term of Industry 4.0. It is driven by industry associations and the German government. And the goal is to create a competitive advantage of the German manufacturing industry. And actually, it is very obviously the technical phenomenon is not restricted to German. So actually, at the same time, we know in US, they called it industry internet, or Internet of Things, right? In France and Italy, it was called smart factory. And in China, we call it the integration of information technology and the industrialization operation technology. So let's have a quick look on what is Industry 4.0 based on some keywords, right? So first, we should have cyber physical systems as a platform. We use the IoT technology to connect all the machines or all the things in the physical world. So we can collect very many big data and use this data and use the AI technology, we can realize the autonomous system use the autonomous system to realize the self-organization production, to do the lot size 1 production for the highly customized production. And we also at the same time can do the performance management to increase our production efficiency and quality. So we can do the integration, we can do the interaction and intelligence. And actually, from industry perspective, yeah, we would like to talk Industry 4.0 measures through 2 dimensions. The first, we would like to do it to realize, use the Industry 4.0 to help enterprise to realize we call it horizontal integration. Here you can see in our business process, we will start from the R&D, and then we will go to, we design our products, and then we sell it. We need to use the supply chain to do the purchasing and got all the materials of the products, and then we do the manufacturing. After that, we deliver it to our customers, and we also provide aftermarket service. So we use the IoT technology. We collect all the data from every business process. For example, we got the design data from the R&D. We got the customer information for the sales. We also can collect all the information, such the transformation information, such as the location, the routing, and the temperature of the car. We collect all this data during the whole supply chain, and then we collect the information from the manufacturing, how it work out, how to assemble it, which materials it used to the manufacturing. And also we can monitor how the assets or the equipment's working and collect all the parameters through the equipment to the platform. We call it the cyber-physical system, right? Maybe it is an internet platform on the cloud. So we can use those data based on the business process to create the service or the applications to provide the service to the enterprise. For example, we can go to design the digital product. We also can do the energy management. We also can do the resilient production. Even we use the AI technology to do the predictive maintenance to the equipment. Another important dimension, we call it, is vertical integration under Industry 4.0. So we have the major 5 scenarios of the connected. So first, the integration is we connected from the top level, the enterprise level, to the shop level. Yeah, we collected all the order information to the manufacturing and then send it to the machine to produce the products. And then, yeah, we connect all the machine. So we realize the machine to machine. So in the, for example, in the production, if in the first step, we have any machine got wrong, and then in the following steps, other machine will know how to deal with it. And the third connection is we connect with the e-commerce. We connect with our consumers, so we can go to know where are they and what they like to get, what kind of products will satisfy our consumers. In order to organize the production, we also need to connect with our suppliers. Especially, we can see this year under the COVID-19, so we got many production vendor suppliers didn't got enough time, or they cannot go to the shop to do the production, materials production. So yeah, we need to collaborate with them to find a more strong or resilient supply network for our manufacturing. And then, yeah, so based on the IoT technology, we would like to collect all the information from our machine so that, yeah, we can monitoring on the machine cloud to see how the machine runs. And we even can do some predictive for the health of the machine, to do some action item in advance, not just go to fix it until it was broke. Okay, so after the so above the 2 dimension is what we talking about on Industry 4.0 at the beginning. of 2013, when we just talking about, when we just raised the Industry 4.0 concept, right? So 7 years passed. So we can see the Industry 4.0 has a great evolution for the future productivity. And also SAP has been engaged in the Industry 4.0 discussion all along. So in 2011, when Industry 4.0 began an academic discussion of the concept, SAP was an integral part of the definition. And over the next 2 years, between 2011 to 2013, SAP was an active participant and a member of the Industry 4.0 working group to define the initial implementation recommendation for the strategy. And in 2015, the Industry 4.0 strategy was expanded to include input from additional companies, associations, trade unions, science, and the political parties. It embraced new trends and topics. After digital applications and products had already been widely implemented, the development and the use of data, business models, and artificial intelligence were anchored in the work as cross-cutting topics in 2018. So in 2019, the Industry 4.0 Consortium and its partners, including SAP, presented the 2030 mission statement for Industry 4.0, which highlights interoperability and sustainability as central guardrails for global open digital ecosystems. So also at the same year, SAP announced the company initiative Industry 4.0 Now to provide applications and advanced technologies that bring to life Industry 4.0 intelligent enterprise processes. So why we said Industry 4.0 is important, from here you can see the potential value delivered by Industry 4.0 for manufacturing industries is huge. Yes, it's $3.7 trillion. So today, according to the reports of McKinsey, we already know that 68% of the companies, they already start to consider Industry 4.0 as a top priority. And 41% companies, they are still in piloting for Industry 4.0, but it is not enough. We need to do the Industry 4.0 at a scale, but now only 29% of the companies already deployed on Industry 4.0 as a strategy. So we still have a lot of things to do. Yeah, for Industry 4.0, it can help the companies to drive the competitiveness in the current dynamic market, right? The manufacturing environment is changing. The focus is no longer on capacity, but on the ability to respond quickly to customer needs and the market changes while still controlling cost and quality. Until recently, supply chains were mainly measured by efficiency metrics. Today, new trends are emerging that present complex challenges and put supply chain and manufacturing at the center, not only for business success, but also of a company's differentiation strategy. So companies in manufacturing industries face numerous challenges. They need to produce smarter products while maintaining high quality in volatile markets. Customers demand individualized products down to lot size 1. Life cycles of products get shorter and shorter. Faster time to market is key to staying competitive. Business models change from selling products to delivering solutions. At the same time, there is intense price and margin pressure to become more efficient and drive productivity gains while increasing resource utilization. Beyond labor productivity and assets efficiency, the next performance leap in factories will be through end-to-end effectiveness of production systems. Mixed mode manufacturing is becoming the new norm, where you must support both process and the discrete industries. Your production processes must evolve to support the future demand and the customer requirements. Optimize manufacturing process to minimize negative environmental impacts while conserving energy and natural resources and establish safe working conditions has become a key objective of most companies. So smart factories leverage digital technologies to gain significant improvements in productivity, quality, flexibility, and service. So in order to support our customers better and simplify the digital transformation, SAP had made Industry 4.0 as a top priority. So in October of 2019, SAP therefore started a program across the various lines of business in SAP and called it as SAP Industry 4.0 now. Actually, it is SAP's Industry 4.0 strategy. So it can help to move digitalization and Industry 4.0 from factory-focused initiatives to a company-wide competition-beating business strategy. And at the same time, it can combine manufacturing automation with enterprise business execution. So SAP's solution portfolio for Industry 4.0 is focused on manufacturing excellence, but also on the connection to the business process to support the customers in the best possible way. And now here is a video I would like to share with you on what is SAP Industry 4.0 now. Okay, so and then, yeah, you can see here's the architecture of the Industry 4.0 now by SAP. So we would like to, horizontal integrate all the business process from the marketing, sales, service team to the whole supply chain to do the production and logistic, and also cover the back office activities like the IT, HR, and resources. And then in the middle is the major of the 4 scenarios for the Industry 4.0 now. And we would like to utilize the We would like to utilize the technology like the artificial intelligence, the data-driven processing, and the IT-OT integration technologies together to support the 4 major scenarios for SAP Industry 4.0 now. The 4 scenarios are, first is the intelligent product, and then is the intelligent factory. The third one is intelligent asset, and the last one is empowered people. So it means, yeah, so in the intelligent products, we would like to support the customers to design the most smarter products. We use the latest new technologies such as the IoT, and also when we do the design, we will support the customers to do like do the design more configurable, and also to support the customers to easy to be better to transfer the design information from engineering to manufacturing. In that time, to shorter the design time and reduce the lead time of a new products go to market. And then in the intelligent factory, in the intelligent factory, we would like to support the manufacturers to connect all the machines to the IT system with the OT systems, and we can do the collect the data. We can realize the data driven to do the monitoring, and also even to do the predictive for the running of the factory, and we can connect all the information to better track and trace all the production and checking how the machine running. And to the intelligent asset, it is also a new trend for our customers, for the manufacturers, when they provide, they are not only provide the solution, the products to the customers, they also provide the whole solutions to their customers. They can provide more maintenance, like the equipment maintenance to their customers, to get more margin on that. So for the intelligence assets, we can support the customers to monitor all the machine to check how they're running, and also collect the data to and anticipate to predict the healthcare and prepare the spare parts before it was broke down. And for the empowered people, now we know with the development of the technology, we got many robots replace the laborers. But however, in the shop floor, we never can, we always need people be there. But we can provide many support to the people to reduce their, to help them to be easier on the job. We can provide more data to the people, help them to make a quick decision, right? We even can help them to do the analytics and provide the options of the correct actions. And also, we can help to protect the people in the manufacturing environment. We can check the heartbeat of the people in the remote area or in the area without any people, and we can check the status of the air. Is there any poison air gases in the environment to help to protect the people's health? Okay. So, and also in 2019, SAP also leading and participate to set up the Open Industry 4.0 Alliance. The mission of the Open Industry 4.0 Alliance is to creating customer value by promoting interoperable Industry 4.0 solutions and services, following a common framework developed by the Alliance to drive the digitalization of the factories, plants, and the warehouses of our customers. So actually for Industry 4.0, it is not only one or just a few companies can do. We need to create a viable ecosystem. We need to work together to ensure the collaboration of asset operators and the manufacturers, and to deliver the value to the customers. So we can see now we already have 53 companies joined the Open Industry 4.0 Alliance. So these companies, we can see they come from the equipment vendors, the component vendors, and also some network vendors and service networks, and the service vendors, like SAP is the software vendors for this one. Yeah, so we trust, we also hope this Open Industry 4.0 Alliance can help to accelerate the adoption of Industry 4.0. Yeah. So, okay, so that is what I would like to present today. If you want to see more information, you also can go to this website through the links here, and also can contact with us by phone and by email, yeah, to get more information on the Industry 4.0 now. Okay, thank you so much.
Thank you, Carol. Thank you so much for your very much professional, I think, report on the fourth industrial revolution from the perspective of the manufacturing. It's quite impressive. Next speaker, let's welcome Mr. Firas for Diab, Chair of WFEO Young Engineers Future Leaders Committee. Mr. Firas, please, the floor is for you.
Good morning. Hello, everyone. I wonder what someone would speak after these very interesting presentations from Prof. Gong and Yohan and Carol. I will do my best to present something at my capacity as the chair of the WFEO Young Engineers Future Leaders Committee. Let me start by putting my presentation. I'm assuming now everyone is seeing the screen. Today's topic, we're really talking about two things which are, or three things which are of major importance for engineers. We're speaking about a sustainable future, and we're speaking about the fourth industrial revolution. And these two, they have different components, and they one completes each other. First of all, let me start with the background of the Young Engineers Future Leaders Committee. Many of you know about the World Federation of the Engineering Organizations, and this federation constitutes of several standing committees and several other committees. The Young Engineers, it constitutes of official members for the National Engineering Associations, which are members in the WFEO. We are trying in the Young Engineers Future Leaders Committee to be the voice of young engineers, and the young engineers are really the population that are the drivers of the creativity, drivers of technology development, and drivers of innovation. We're always promoting involvement of your young engineers in world's leading activities, and I assume today's participation in the China Tech is one of these activities. We're trying always to allow young engineers to gain knowledge and experience and to get involvement in attending for global policies. This will definitely prepare them for the future and will give them like leadership roles. Also, which is something which is, I guess, Prof. Gonki have raised, which is the participation of the young engineers around the world in advancing the Sustainable Development Goals or the 2030 Agenda. This is also and always have been a major input from the committee to the Sustainable Development Goals. You know, when we speak about the engineering, we definitely say and know that engineering is an important field of sustainability. And the engineer's role in the sustainability is very important. They provide options and solutions. These solutions definitely should minimize environmental damage and maintain a sustainable environment. Engineers now are really helping to build a better world by signing the declaration to advance the UN Sustainable Goals. Engineers worldwide have a clear mandate about their role in helping communities live more sustainably. These are the 17 development goals. We have like the agenda of 2030. The committee is formed with several working groups. We're like working on different topics to advance a number of these sustainable development goals. These sustainable development goals, they are not like individual goals. These goals are integrated all together, and the advancement of any goal would lead in a direct way or an indirect way in the advancement of another goal. Now, if we'll go to the fourth industrial revolution, and now allow me to speak in simple terms for young engineers who are partially probably involved in this fourth industrial revolution, and many still are trying to gain knowledge in this. When we speak about 4IR, I mean that we're speaking about a combination of advances in AI, artificial intelligence, robotics, IoT, 3D printing, quantum computing, and other technologies, and also about genetic engineering. We all know that we have passed since 200 years in like three industrial revolutions, starting from 1800 with the Industrial Revolution, which was revolving about steam, which was revolving about water and steam. And then we came in the 900s to the age of electricity, where we were talking about manufacturing using electricity. And 40 years ago, we have started speaking about the automation and the computer technologies and the automated production. And now we're living in the age of the fourth industrial revolution, and we need to make sure that this is understood and clearly understood by young engineers who will definitely have to contribute for the success of this revolution. We know that, and everyone should know from the young engineers, that the 4IR is unfolding within and around us, and it's pushing us beyond new forms of mechanism and challenging about our ideas about what it means to be a human. When we speak about the Internet of Things and the IoT, in simple terms, it means that it's designed to establish a connection between the physical and the digital worlds. When we speak about robotics, we know that robotics is evolving, and especially cobotics, which is designed to interact physically with the human in a collaborative environment. This will be the future key of the industry. Also, when we speak about the big data, we all know that information is power. Big data allows massive data management and interpretation for business purposes. And also, we know that using 3D and 4D printers, these printers will help by developing prototypes, and these prototypes will be used to produce later and allow for a quick sale, and these will be like participating in the future of e-commerce and in the future of businesses. Also, when we speak about augmented reality and virtual reality, this is a combination. Here comes the role of the computer science, where we can have like an enrichment in the visual experience. Other technologies, I guess that we have speak about these. Maybe we get to know that when we speak about the 4IR, we're speaking about nanotech, advanced material. We're speaking about autonomous vehicles and smart transportation. We're speaking about biotech. We're speaking about the blockchain. All these form the peers for the 4IR. You know, when we speak here about talking about the advantages of the 4IR, we're speaking about a speed in progress. We're speaking about a wide coverage, and definitely we're speaking about data, and not data, it's a big data. And then we're dealing with increased productivity. We're dealing in efficiency and equality in processes. We're speaking about a greater safety for workers, and especially workers who are been working in dangerous environments. We're definitely giving like competitiveness by developing customized products that satisfy consumer needs. And exactly, we're speaking in having like enhanced decision-making with database tools. And here, I guess that Prof. Gonki in his presentation spoke also about the transformative potential of the 4IR. When we speak about the potential of the fourth industrial revolution, we're definitely speaking about a revolution that will lead, hopefully, in fighting poverty and inequality, in reinventing labor, skills, reskilling, and the production, definitely in modernizing agriculture and agro-businesses, in improving healthcare and human capital, and at the end, this shall lead to encouraging economic growth and structural transformation. Talking about the 4IR will allow us here to speak about national strategies. These strategies shall be done at the level of each country, and these strategies shall be done within the different organizations or the association in the countries, and definitely it needs to go up to a scale of regions. You know, when we're speaking about different countries, neighborhood countries, to share experience. Every country shall speak about, in order to allow for 4IR, they need to speak to support by building an environment that is favorable for the development and the uptake of the artificial intelligence technologies. They need to educate individuals to build the AI skills and educate the users. And definitely they need to enforce and adapt the traditional policy tools that tackle economic and societal challenges posed by the artificial intelligence. And finally, they need to steer and ensure that a human-centric approach guarantees the highest level of welfare for the citizens. At the end, the goal of the 4IR should be a society where everyone, people and young engineers and women, feel empowered, not threatened by the 4IR. Now, speaking about the young engineers, they are at the heart of the 4IR. And the young engineers, at some point, they have to take major roles that they will have to play. It will be like developing robotics compatible with automation. They need to generate new sustainable power technologies. They need to design self-driving cars and smart transportation. They need to help in making 3D printers for everything. They need to produce satellites and tools used in space. They need to create sensors, GPS and tracking tools, and definitely they need to make nanotechnologies for several and numerous applications. This would be part of the roles that young engineers will have to play, and they are currently partially playing in the nowadays. When we speak about the young engineers and the 4IR, we need to speak about the skills. These skills that need to be to have by all young engineers. We're speaking about workforce readiness. You know, we need to have a digital literacy, a resume writing, self-presentation, time management, professionalism, and social norms. When we go to the soft skills, we're speaking here about critical and creative thinking. We're speaking here about the teamwork, about the self-confidence, about leadership capabilities, about cultural awareness, and professional communication. When we speak about technical skills for young engineers, we're speaking about the coding, we're speaking about financial management, mechanical functions, technology-based skills, and definitely the most important is the computer programming. And we come here to the entrepreneurship, which constitutes a major part. And definitely young engineers around the world are trying to set up businesses, starting freelance works and startups in order to develop a self-starter within a work environment. Here, we'll be mentioning about a balanced roadmap for the fourth industrial revolution implementation. We have mentioned the national technology, strategies, and policies, which means that we need to develop policies related to science, technology, and innovation. We have mentioned, or we need to mention about the productive research, development, and innovation ecosystems, because at these ecosystems, there will be a transfer of policies and mechanisms between universities, between science parks, incubators, and between the entrepreneurship initiatives. We need to talk here for a balanced roadmap about socially conscious investments. Technological development must be governed by human rights approach. Connecting the capabilities of the 4IR necessitates adhering and protecting human rights throughout the process, and this is very important. And definitely, when we speak about a roadmap, we need to speak about the skilling and the retaining job and labor market restructuring. We need to know, and young engineers need to understand that there will be a shift in the types of skills for the future, immediate attention to skilling and reskilling, which could be facilitated through ICT-enabled platforms. Lastly, the Young Engineers Future Leader Committee at the WFEO would like to put here a key recommendations. The key recommendations will start by young engineers will need to contribute to the community and make a difference by embracing the UN SDGs in addressing issues of inequality, resource utilization, climate change, and changes in living conditions. 4IR technologies can make us more productive, definitely, and effective. Currently, we are learning to use technology. In the future, technology will learn about us and help us to be more productive and responsive. The 4IR technology is slowly penetrating a number of domains of human living. In a way, it's a great opportunity, a great equalizer, but we need to embrace it. Young engineers have to shape the fourth industrial revolution and direct it toward a future that reflects our common objectives and values. Young engineers, lastly, will need to shape a future that works for all of us, but putting people first and empowering them. Thank you, everyone.
Thank you. Thank you, Firas, for your very inspiring presentation. Young engineers are the future of sustainable development, and you are the chair of the Young Engineering Committee. So thank you once more for your excellent presentation.
Thank you.
And with this, we already finished the first presentations, and let's move to the response Q&A session. Now, we received actually 3 questions. I suppose all of you, our panelists, can see the questions. Let's go one by one. The first one is from Sansan Wang. I think it's from China. He said it's interesting that you mentioned about the importance of digital technology in SDG. But I think COVID experience has well proved that for the developing countries, leapfrog directed to enjoy success of 4RI for the developing countries. Maybe I wishful thinking because the physical infrastructure transmitting data is still significantly underdeveloped. I wonder what the view of the panelists may be on this. Does it mean that the development priority should be changed for the new trend? So, who would like to respond to this first one?
Would you like me to go, Dr. Peng?
Sure, Yohan, please go ahead.
Not a problem. I think Shenzhen's question's a very good one. And what I've actually seen is he's absolutely right. We're quite a lot of the developing countries were able to leapfrog and get into new technology. So if you look at from a digital perspective, you know, what are the world's most digitally savvy countries in the world? And you would see quite a lot of them are small in nature, quite a lot of them are either new countries, so they haven't had quite a lot of the legacy systems there to work with, but there is always that hardware component that comes to it, right? So if you look at I spoke earlier about autonomous vehicles. And if you look at autonomous vehicles would need almost a smart city infrastructure for autonomous vehicles to navigate and for them to do what we expect it to do. So the infrastructure that we put out needs to also have a smartness within it. You can't just simply expect the car to be having all the smarts without the infrastructure having any smart. So for example, in Australia, in the Australian context, one of our state governments have basically mandated that all infrastructure that they are committing to need to be having the smart digital infrastructure embedded. So they can't, for example, no longer just build a highway as it is. They need to look at what sort of sustainability components have been factored into it. How is technology being used? What is its future value and use? And let's say if there's an autonomous car that's driving along there, are the speed signs that we put up there, are they in a way that the car's able to read them, or are they just the normal speed sign? So there's quite a lot of thoughts that's gone into it. So in terms of development priorities, the priorities within what you actually implement needs to certainly be contemporary. You can't no longer go in there and build just a bridge. You want to make sure the bridge is built in a way that you might have some load bearing, and there's some sensors there that would actually tell you and the people who are actually managing that infrastructure that look, it's time for you to come in and do some preventative maintenance of that bridge, or look, it's time for you to now replace certain components, etc. So there is that digital component that is there that needs to be embedded even in physical infrastructure. And then soon, we haven't seen the biological world really coming in that much, but it is not too far away. So it's a very good question. It is happening, but if you don't have the legacy systems, such as a developing country, yes, it's easier for you to leapfrog. However, you do need that physical component, but they need to be smarter physical investment rather than just the traditional investment.
Thank you, Yohan. Thank you for your very deep insight for this question response. Actually, here we have a participant raise his hand. So let's have Ajabo, Mr. Ajabo. Do you want to say something? We have a participant who want to raise some questions, maybe. If not, we move to question 2. It says, engineer always wanted to make things better with also the help of technology. We try to innovate things. My question is, what can you say to those consumers who are afraid to use or accept these kind of innovations, such as self-driving cars? So, dear friend, who want to respond to this one?
How about I go again, and then the others can pick up?
It's your question because you mentioned the self-driving cars or trust, something like that. So please, thank you, Yohan.
Not a problem. So it comes down to, that's why I said it's really important that we add trust to the equation. When you look at 4IR, there's so many unknowns that we're only unraveling now. So in that sort of environment, trust is really, really important. So if I use, let's say, an example again, and I'll use a bridge again. So there is this bridge that the engineers have carefully built. And if the consumers, the pedestrians, know that if you try and cross the bridge, and if there's a likelihood of the bridge, you know, falling down, collapsing, would people be using it? Absolutely. Most people wouldn't, but it depends on the probability. But the same thing, I mean, we know that our engineers are very, very good, and they build really robust, really good bridges. So nowadays, the likelihood of that happening is extremely low. But with new technology such as autonomous cars, there are quite a lot of unknowns, and people's appetite in terms of risk to go, okay, look, if I actually try this new technology, what are the likelihood of that something going wrong? And if it's high, obviously there'll be a lot of people who are not willing to take that risk. But if it's low, then people will be using it. But it comes as with mainstreaming the technology as well. The more autonomous cars we make, the more likely that people will use them, more likely we will be able to address some of the nuances, some of the things that people, the engineers, wouldn't have even thought about, some of the use cases, and we will be able to fix them, and add the cyber risk to some of it. So what you don't want is you're driving along the road, and someone's able to hack into your autonomous car and take you away from where you're supposed to be going, or, you know, in worst case scenario, you know, taking you down a hill or whatever. But the likelihood of that happening is extremely low, but we need to make sure we provide the trust that the consumer really needs for them to be satisfied that the technology is actually working for you. It's helping you. It's helping you to be more flexible, because you don't need to be actually driving. The car's driving itself. So you could be more productive. You could be reading the paper. You could be doing some work. You could be reading a book, whatever else that you would really like to do, rather than actually spending time driving. So there's a lot of efficiency in having autonomous cars, because the car would also be able to find the most efficient route. So there'll be, you will save time, you will save fuel, therefore it's going to be a lot more sustainable. You're not emitting as much emissions, and when you look at all that, it becomes a lot more sustainable. But we need to make sure that the trust aspect is addressed, so that the consumers can use it with confidence, and there's going to be more and more of them using it. So engineers need to make sure that trust is really important. As I said in my speech, we already have a really great name, and we are trusted. We are a trusted profession, and we need to maintain that trustworthiness.
Thank you, Yohan. Now let's move to the third one. I think this one maybe is go to Miss Tsai. So how what's your idea about a free webinar with certificates, or what's the situation for SAP?
Yeah, so first I would like to appreciate the confirmation from these friends, Akdo, right? So very thanks for your confirmation to SAP. Yeah, yes. So actually more than 80% of the top 500 companies in the world are using SAP, and we also got more and more customers around the world. Yeah, but as I mentioned, so actually SAP have a very complicated, very complex end-to-end solutions. We have many products. So actually our products and then our solutions not only just a free webinar we can get to understand. So especially for the certificates, we will request the colleagues all the consultants need to study it for required hours, maybe more than 100 hours and in the class. And also we need to have some examination, pass the examination to get the certificates. So actually, yeah, it's not just a free webinar. We can provide the certificates to the products. So I think what you need is first you need to get clear which products, which solutions you want to learn from SAP, because we have many, we have hundreds of products to provide the IT solutions to our colleagues. And yeah, but of course, from SAP, we also provide many free webinars about our products. Some maybe some entrance introduction to our customers and to our partners. And also we always provide the new features of our products for the new release version, right, to our partners and customers. Yeah, but for certificates, yeah, I think you need to, yeah, quite a lot of time on that. Okay.
Thank you, Carol. Here we have the last one. I think this one goes to Firas.
Yeah.
What advice can you give to this young?
I clearly understand, and everyone here understands the trouble that young engineers and recent graduates are facing everywhere. You know, the only thing is that young engineers needs to make sure that they're getting the proper skills and they're getting the proper tutoring to get into the industry and get into the job market. They need to always collaborate with their national organizations to make their voice heard. They need to put more pressures on the institutions, and they need to put more pressures on the national representatives of their country everywhere to make the voice of young engineers heard in the industry. I know it's not something easy, but it's like something that that you can take it with time. Things are not smooth. I understand that everything we're facing, like maybe at every part of the globe, we're facing like a partial or total recession, but this doesn't mean that we need to sit down and wait. We need to continue like raising our voice and making statements to have like a good future for young engineers. Thank you.
Thank you. Thank you, Firas. Actually, we still have questions come in, but the time limitation, I would like to call an end to the webinar. So once again, I would like to give my sincere thanks to my colleagues here to have this webinar to be very successful. And we will have this webinar recording on website, and also the come-in questions, maybe later our speakers can respond to those. So thank you once more. Thank you very much for your contribution to this webinar. And I hope to meet you in the future face-to-face and have more communication. Thank you, colleagues. Have a good day. Bye-bye.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye. Thank you, all participants, for your attend this webinar. Thank you all.